Hey guys, the saga continues. So I'm back, and we're going to talk about 1.2. Let's get started. We've got the three data structures we had previously talked about, wanting us to describe parsing in the common data format. Some of these things kind of blend together from 1.1 to 1.2, and so I may end up overlapping on some of this. But what I did here is I referenced the three different libraries that I used during my tests, and we'll cover those here. So you can go to python.org. Any native library will be there. The documentation will be there for you to read. Pardon my pausing. I've got some things going on in the background. Native parsers we're going to use for XML and JSON. And then as far as I know, there is not a native parser for YAML. If someone knows of one currently, please let me know. Usually what Python does is they'll take kind of the most popular library, and then in later releases they will integrate that into the code. But as of right now, I'm not sure of a native library that's in use. So okay, so here's what we're going to do. I broke this up into sections, and we'll go in order from XML, JSON to YAML, and we'll just start describing the parsing. So each one, we covered this before, which I do want to, replace one of my comments in the previous video. I just watched it. It was my first video, and I said microseconds instead of milliseconds. You probably caught that, but I just wanted to get that out and off my chest. I will try to watch these videos prior to uploading. I didn't know that you couldn't upload or edit them once they were on YouTube site. So with that aside, here's our structure. So XML, and now again, we already covered where these data sets are. You can pull these up and look at them yourself. But this is the structure. All of the data itself is the same between all three structures, and we just cover a few things, right? So in XML, the main thing to pay attention to is very HTML-like, right? You have a hierarchical structure of tags and other tags that can be kind of embedded in those tags. And so, as you can see here, every element is represented as a tag and a closing of that tag. Now, XML does have what's called attributes. All right, so you can go in here and you can define an attribute. This would be an attribute. As an example, this price equals free, right? And the best way to get it. There's no rules around how you use these. I tend to just ignore the fact that it has attributes because, well, if you build the structure hierarchically, you can build attributes using tags, right? So I'm not real sure why someone would want to use this. If someone knows a good answer to that, please make a comment, and so I can review and maybe make some additions or modifications to this. And then each element has a text to it, right? And so this would be an example. So I've got a tag, a closing tag over here, and then in between that is the text. And so if I wanted to reference the text inside of that tag, which would be an equivalent of like a value. So this would be a key value pair. And the value would be the text. There's what's described as parent-child relationships, sibling relationships, and just in general for the structure for XML terminology. Sometimes those terms are used in the code in the parsers themselves, so you just need to be cognizant of those relationships. And I put that here. So here's an example, right? You've got a tag and a closing tag for that parent. So parent's on the outside, child's on the inside, and then hierarchically the child is under the parent. And subchild, right, is another term. I took the structure of this this XML file here and just drew up a representation of that data set. And this is just, for instance, this switch object, right, where all of these children and sub-children underneath switch represents that one object of the switch if you were to serialize it. And obviously I could take this structure here, and if I added another switch, it would just be under the root over here somewhere. And you could, iterate over the switch, go down into all these different, elements and use them however you want to. From the interface element, so I'm just as an example, if I went to the interface element and I had that inside of this parser, you could describe the relationships, and that's why I put this here to help better understand those relationships. So there are five children elements, and you can see those here of this interface. There are two siblings, and that would be kind of east-west in this structure here, and one parent, which would be the switch. And at the top level there is the root. And you can see that I took this out of Visio. You can see the highlight of this element in Visio right down here. But anyway, we'll move on here. So I put the function down here. There's also, again, I don't know why I added this reference down here other than maybe an assumption that it was missed up above while we're talking about this XML. So I did take out 4 kind of commonly used functions. There are a lot more functions in here, and that's one reason why you may want to save this and reference. It's not like it would be hard to find, but if you looked in the Python library for XML, you would find it. But all these functions are listed right here. And there are several other functions that in most cases I would consider to be not commonly used. And so I just kind of took what I thought to be the most parsing functions out that you will likely use if you are parsing XML. So let's cover those. So right here you have the element iter, which this is just a function, a sub-function of this this particular element. Once you get to that element, and in the function we can talk about that once we get there. But for instance, from the root, once we have parsed this into the XML library, we can find these elements, and then we can execute these functions from the position of that element. So as an example, this iterates recursively over all the subtree below the element, right? So it's basically going to iterate over everything underneath the particular element that you're looking for. And the only reason that some of these things are important is because some of these functions, depending on your data structure and what you're looking for, is going to determine how fast they're going to return. In a lot of cases, it really won't matter. Most people will go in and just do like a find all, for instance, which finds only elements with a tag which are directly children of the current element, right? And what that'll do is for instance, it'll look, if you're the switch, for instance, it will iterate over these children, looking for a specific tag. And then they'll grab that element and they'll move further down, etc. But for instance, let's just assume you're looking for a single object and you want that to not iterate over everything, or maybe you just want to return the first object that is in an array. You would use find, which would be generally faster. And that it's commonly used terminology in coding, the find all and find. Find all is kind of an assumption that it's going to return an array of some kind. So just it might be good to remember that. And then this get right here, which was, we talked about this earlier, the elements attributes, which, if you had, let's say, an interface tag, a closed interface tag, and you had an attribute of whatever, you could technically put all of these as attributes. You could use that. It's just not something that I feel like is commonly done. At least I haven't seen commonly done. Not that I've looked at just an enormous amount of XML, but to me it doesn't make a whole lot of sense when you could just structure it hierarchically with tags. So we can go over the function that I wrote to do this, and again, it's a really simple function. I just kind of wrote, let's just say, a test case. When we get into the test-driven development, we can talk about that. And it was a simple test case, and then did the exact same work across the 3 different parsers, and you'll see once we cover this. But so the first thing that we do here, and I covered this before, is basically getting the file. And the reason I wrote it this way was and actually I need to change this because this is actually 1_2 now. But it was to replace the folder name, etc., and be able to kind of use this file from multiple locations within the code. So this etparse is a function inside of the XML library, and if I could show you the top of the code, I could show you where that's at, but ultimately it's imported to just be ET, so that's why you don't see the previous code for XML drilling down into that function or object. And what this does is once you parse, it's taking this this file and returning that XML tree object for that library into tree. And then down here what we do is we take the tree, which has a built-in function for getting the root of that parsed data, and returning that, and we call that root. And then this is just a simple process of kind of using those functions that are built in for the elements themselves at the element level. So for instance, I am taking every switch, and I don't recall if we have more than one up here. Oh, we actually do. But for every switch in the root, we're looking, we're first finding that and returning the switches. But for every switch, we're going to do the following processes. First thing, create a new dict object, which I called switch out. And then I actually went ahead and put the dictionary keys with none values in prior to doing any kind of looking for this. And the reason I did that is because, for instance, if there's no value in there, it could throw exceptions later. And so I just like to make sure that I have something clean prior. And if nothing returns, then, well, then I'll just have an empty object there. Not empty object, but an object with null values. And then what I do is I try to find the switch out host, which is switch.find hostname.text. And if you look on switch here, I'm basically just looking for this find, which is not a find all. I know that there's only one hostname tag underneath switch, and so I can do a find and then basically just pull the text directly out of that, return that into this this dictionary for hostname here. And I did the same thing for serial numbers. I thought I did something a little different here. Oh, yes. So what I did was I looked at the top level element here, which is serial numbers element. And this was just because the plan was, well, a lot of the devices, they'll have multiple serial numbers, and I'm sure you've seen this where you've got a chassis serial number, and sometimes you've got a serial on the code, and you know there are different serial numbers that you may want to store and be able to retain, and that's the only reason that I did it that way. So I returned the element for the serial numbers, but this is actually a dictionary type object here, right? So it's another tag that's basically chassis, and inside that text is the serial number, and you can see that up here. Let's see here. So so you can see that under switch there is an element of serial numbers, and inside that serial numbers element there is a chassis element, and that's where I put that serial number. So again, you could have another serial number inside of here. I might put, I don't know, software code or whatever, serial number, who knows, because sometimes serials will follow the code. Let's see, where were we? And find serial numbers, and then yes, text, and then even though our objective was really to store this data, we printed it out just to show that we have it. Obviously, we could store it wherever we wanted to. Something to note, I mentioned before, XML is the oldest of these data formats, and so you're just gonna have to make your choice on what you want to use. But it is the highest supported. Again, a lot of this is going to be repetitive. So here we cover the JSON data set, and again, it is the same data and same structure as the other data formats. As you can see here, this is my personal favorite code. Reason being is that this particular structure is the same that you would see in Python. It is literally the exact same. If you took these, this value, for instance, this is a key value pair with an integer, right? Same thing here, same thing here. This is a dictionary that contains all those key value pairs. And this would be a key inside of a dictionary where its value is a dictionary with these key value pairs, and so on and so forth. And that's the pretty thing about JSON is that you have all of these embedded data types that just flow naturally. It just makes a lot of sense. You can store almost anything. Anything that will just kind of generally be serialized without any problems. I have run into some issues where some objects were not serializable. I can't remember exactly all of them, but there are some. That doesn't mean that you could not find a way to serialize it, but in general, most things are serializable. So, and JSON works great for that. And I did mention some of this. Again, you can read through this material just as kind of a recap, and it's just under exam material 1-2. Down here we talk about the data structure, which is a little bit different than the XML was. That's not necessarily just because they're so much different from a structure perspective. But I'll give you an example. At this top level here, this is actually a dictionary, and if you look at the XML, you could consider it a dictionary. You could consider this a key, and then, for instance, the data underneath it as a value. But you look at JSON. The top is basically the same thing. You have a dictionary, here's your key, and then your value here is actually a list of dictionaries, and each dictionary represents another switch. And so I drew out that structure here to help follow along in parsing. And so we can cover this next function, right? Parsing JSON. So I did this kind of the exact same thing. It's the exact same objective. One thing you'll notice right away, look how much smaller this code is than let's say this code, right? It's just because it's already code. It's already ready to be code. You're not using a parser to try to abstract that data structure to code. It's already there. So yeah, simply put, we just import it from the file read, which is the string, and then this switch list here. We're going straight into it, right? This is the same thing you would do in Python. This is a dictionary, JSON object. I'm just going to basically return this switches dictionary to switches list, and if you remember, it was a list. And then for every switch, what are we going to do? Well, we would generally, the objective here is to store it. We're just going to print to say that we have it. And here's my print format, a host name, and then I got my variable here, and the chassis serial variable here, and then I am just switch, and then looking for the key host name. And then on my serial numbers, if you remember, I embedded those chassis numbers deeper into the serial numbers. And so what we do here is we call the switch dictionary with the key of switch numbers, and then underneath that we will look for the key chassis, and then that will return the value that we want. So you're free to run that code. These particular scripts are right here. There's nothing special, and really simple from a use case perspective. And then we did the same thing with YAML. Use the data set. It's extremely readable. I love the fact that it's this readable. So the first time I looked at this, I thought, wow, this makes a lot of sense. And how could you go wrong, right? You look at it and it's just, a lot of configurations now you'll see in, for instance, cloud and a lot of the deployments, automation is in YAML, and it's just simple to read. But at first look, you don't really see any issues here, and in some cases there probably aren't any issues. And if it meets your use case, you might as well use it. So positives. It's readable, low storage, transfer cost, super slow in the library that I used, as we notated in the previous 1.1. And again, I'm not real sure why that it is. I'm not trying to hate on YAML. It looks great. I wish I had more confidence in it. I just don't, based on the data that I've collected using the tools at hand. Same structure as the JSON above, and actually if you look at the way that we parse for the objective here, it is exactly the same as JSON. Exactly. The only difference here is the loader is ever so different as far as the arguments, parameters, but whenever we return it, look, it's a dictionary, right? And we look for that top level switches key, and then we iterate over it, and exact same thing. It is the exact same thing as JSON. It is less configuration, code. If I'm writing this out, I could write it much quicker than I could write JSON. Just at the end of the day, from a coding perspective, it ends up looking like JSON, and that is the reason that I prefer JSON. That looks like we hit the bottom, and then let me see if we can look through some of this code. If there's anything specific to this, and there is not, I will go ahead and go over to section 1.3, which I think I previously mentioned. I just could not find a lot of content to really make this particular topic I guess full of content. So simply put, this is something that I feel like most people do anyway. I know that there is a lot of documentation. I actually pulled up Wikipedia. I was looking at different things. They're all saying the same thing, and I think abstractly there's not a lot here, and I will cover what I have. I would like someone to add some comments and information to try to help me understand and clarify maybe what I don't know, but I will cover what I have here, and we'll go from there. So the main thing that they try to emphasize here is that it's kind of an iterative process, which I always assumed was normal anyways. Again, add a test, right? So we go in and we say, I want to do this. This is the requirement. You gather that from your customer or client or whoever you're dealing with. And so that's kind of your baseline for your test. I want to test this. And then at that point you want to check to make sure the code doesn't already do that, and make sure it fails to do that. And then there is an iterative process that is basically described as a dirty coding process. You would just write your functions, try to make it work, and then run the tests. Does it work? Does it not work? Okay, it doesn't work. Let's refactor. Write the code, run your test. Refactor, write the code, run your tests, and you just go through this iterative process until you have it in a way that it meets the requirements. It does all the functionality, and it's refactored in a way that's clean and readable, and makes sense to everyone in the code base. And yeah, I did happen to note the fact that it did reminisce me from some earlier music of my time. So here I kind of abstract it. I just said kind of in a paraphrase what I'm conveying here. So there's a reference to code refactoring and what that means from a terminology perspective, but I do not have a lot of content here, and I probably will add some, but as of right now, this is where we are. So I'm going to go ahead and end the video, and if anyone has any comments, some things we need to add in here, and some things maybe that you can enlighten me about in some of these the processes, especially this test-driven development thing, because I just always assumed this was a normal workflow. Anyway, contact me if there are any questions, comments, or concerns, and reach me on YouTube. You can email me. And with that being said, I'm going to end the video. Thank you.